Hey there, today we're doing some mid-level ACT math questions. So if you're following along, I would pause the video whenever I'm reading the question and try and do it yourself, and then watch me explain it and see if you got it right. So let's look at 29. Thomas and Janelle are playing darts in their garage using the board with the point values for each region shown below to the side here. The radius of the outside circle is 10 inches, and each of the other circles has a radius 2 inches smaller than the next larger circle. All of the circles have the same center. Thomas has only one dart left to throw and needs at least 30 points to win the game. Assuming that his last dart hits at a random point within a single region on the board, what is the percent chance that Thomas will win the game? And then we have our answer choices there. So the best thing to do would be to draw a picture similar to this one that we can manipulate and draw distances on. Let's see. And we know that the outside circle is 10 inches. The radius of the outside circle is 10 inches. That's going to be 10 inches. And that each one in between is going to be 2 inches smaller. So, and you can draw on the exam on your paper. So each one of those is going to be 2, right? And the radius in the middle is going to be 2. Okay. So now let's see what the question is asking. Thomas needs at least 30 points to win, at least. So he could get a 30 and win, or a 40 and win, or a 50 and win. So he can go anywhere in here and win. If he goes outside of that, in either the 20 or the 10, he loses, right? So what we're going to try and do, since it's random, we're going to take the area of this circle, right, and put it over the area of the total circle, right? So all we need is to draw let's call this the winning circle, right? That's the winning circle. He wins if he shoots it in here, and he loses if he shoots outside. Since each layer is of length 2, right? Here's 2, here's another 2, and here's another 2. It's going to be 6, right? We got 6 inches. That's the radius of the inside circle, and the radius of the outside circle is still 10 total, right? So let's find the area of A, the winning circle. Okay, that is area equals pi r squared equals pi 6 squared equals 36 pi, right? And the area of the outside circle, let's call that t for total. T equals pi r squared equals pi 10 squared equals 100 pi. So we have the winner circle area and the total circle. Since we're looking at the percent chance that he'll win, we take this part over that, right? 36 pi over 100 pi. The pi's cancel out. We have 36 over 100. 36 chances out of 100. He will win. That's what that means. So that's a 36% chance. 36% chance that he'll win. And that is one of our answers, A. Okay, let's look at the next one, 30. When asked his age, the algebra teacher said, if you square my age, then subtract 23 times my age, the result is 50. How old is he? So this is a classic word problem where we're trying to translate words into an equation. And each phrase, we'll go through each phrase and show you how that phrase is translated into algebra. All right, so first, the algebra teacher said, if you square my age, so if we're looking for his age, right, how old is he? That's the final question. My age, that'll be our variable. We'll call that x. So if you square my age, so that's going to be x squared, right? Now we can move on. Then subtract 23 times my age, right? That's the next one. So 23 times my age, let's look at that first before we subtract it from this. 23 times my age, that's going to be 23x, right? 23x. So now we subtract it. Minus 23x, right? The result is, that means equals 50. Now let's read it through again and look at this and see if it makes sense. If you square my age, then subtract 23 times my age, the result is 50. How old is he? Now we just gotta solve this, okay? So let's see. Since this is quadratic, we got an x squared. Let's get all the terms on one side and a 0 on the other. So we're going to subtract 50 from both sides. That's x squared minus 23x minus 50 equals 0. Now let's factor that. We got x equals 0. This is how I like to factor. I like to set it up before I fill it in. We got x times x is x squared. Now let's look at the numbers that are going to go here. These two numbers need to multiply to give me 50 and add or subtract to give me 23. So right off the bat, I'm thinking 25 and 2. That makes sense, right? 25 and 2. Now we just got to make sure we got the plus and minuses correct. Since this is a negative, right? 1 is going to be plus and 1 is going to be minus. Don't know which yet. Then let's look at this. We got a negative 23. That means a negative 25 plus a positive 2 will give me negative 23. So that's how I fill that in. Now all we got to do is figure out what x equals. We want this to equal 0 or this to equal 0. Let's try this first. X minus 25 equals 0. X equals 25. Now we set that equal to 0. X plus 2 equals 0. X equals negative 2. I don't think the teacher is negative 2 years old, so he's going to be 25, which is G. All right, next is 31. Okay. The distance d, an accelerating object, travels in t seconds can be modeled by the equation d equals 1/2 at squared, where a is the acceleration rate in meters per second per second. If a car accelerates from a stop at the rate of 20 meters per second and travels a distance of 80 meters, about how many seconds did the car travel? And our answers are approximate. 3 of them are, so we could get a decimal answer. Let's just plug and chug. That's what this question looks like. Okay. So our equation again is d equals 1/2 at squared. So let's see what our numbers are. If a car accelerates from a stop at the rate of 20 meters per second. So that's our acceleration, right? 20 is a. A equals 20. And travels a distance of 80 meters. D equals 80. About how many seconds? That's what we're looking for. Time, right? Where t is time, t seconds. So we're looking for t. Okay. So now we just plug and chug. D equals 80. 1/2 a equals 20. T squared. Let's simplify. 80 equals 1/2 of 20 is 10. 10t squared. Now we got to isolate what we're looking for. Divide by 10 on both sides. That's going to be 8 equals t squared. So simplify again. We take the square root of both sides. Square root of 8 equals t. Now, if you have a calculator, let's use it. What is the square root of 8? 2.8. So in between 2 and 3. That is one of our answers, B, between 2 and 3. Let's see if we can get one more in. 32. Which of the following is the set of all real numbers x such that x plus 3 is greater than x plus 5? Okay. And let's look at our answers. The empty set, the set containing all real numbers, the set containing all negative real numbers, all non-negative real numbers, and the set containing only 0. This is an interesting question. We're trying to figure out what numbers would obey this inequality if you plug it in for x. So the best thing to do here is just to simplify. I'm not sure off the bat what that is true for. So we have x plus 3 is greater than x plus 5. Now let's see, what can we do? Let's subtract 3 from both sides, okay? See what happens. That leaves us with x is greater than x plus 2. Off the bat, that's looking a little suspicious to me. But let's keep going. We can subtract x from both sides. Minus x minus x. Cancel, cancel. We got 0 is greater than 2. Now, this is not true for any real numbers of x, since x is no longer in the inequality. So we can safely say that the original inequality is not true for any real numbers x. Therefore, x must be in the empty set, right? Or the empty set is the set of real numbers x, such that this is true. Right? Nothing works. And that makes sense. You might be able to see that off the bat, that a number plus 3 is not going to be greater than that same number plus 5. This question is probably just an intimidation question. You know, there's sets and real numbers, negative real numbers, non-negative real numbers. Don't get bogged down by that. Just simplify and find out that the empty set is the answer. F. Alrighty. I hope you learned something from that. Hope you tried them out. Hope you got a lot of them right. And thanks for watching. Hope you do well on the ACT.